All right, guys, it's Miss Johnson here, and I'm back to bring you our next notes video for intermediate algebra. We are in Unit 1 Notes 2, and today we're talking about solving inequalities. So I can write and solve multi-step inequalities. So just a refresher from yesterday, our 4 steps for solving equations looked like these. So one was I can simplify each side of the equal sign by distributing and combining like terms. 2 was gathering the variables to one side of the equal sign. 3 was using addition or subtraction to cancel that constant, that number with no variable. And 4 was using multiplication or division to cancel the coefficient. So let's just take a second to write down, finish out those 4 steps up on your note sheet. Oh, and by the way, if you didn't get your note sheet out yet, you're going to want to do that. So make sure that's out, something to write with, and probably a calculator is usually pretty handy. So um, and also, don't forget that you can always pause the video should you need more time. And if I move on too quickly or you need to hear something again, feel free to rewind it. Yeah, and we'll move on from there. So let's do just a few examples of these equations that we were solving yesterday. So in number 1, I have -2 times the quantity 3x plus 5 is equal to 4x plus 20. So the first thing I want to do is simplify each side. So I'm going to start on the left. I see that there's some distribution to take care of. So -2 times 3x gives me -6x. -2 times 5 gives me -10. Over here, I haven't changed any of that yet. So 4x plus 20 is what I'm looking at. And then I want to move the variables to both, or to one side, gather both variables to one side. I like to move the smaller one. So in this case, I'm going to add 6x, which makes that go away. But in equation balancing, we always have to do the same thing to both sides. So whatever I did to the left, I have to do to the right. That leaves my -10 left over. Don't forget that that negative was in front of it because that does affect the 10. And then over here, 4x plus 6x is 10x plus 20. Then the next thing I would do is subtract that 20. -10 minus 20 is -30. So -30 is equal to 10x. So now the last thing that I need to take care of is to divide both sides by the coefficient. So divide by 10, and I get -3 is equal to x. So that is my solution. Let's take a look at number 2. In number 2, -7 times the quantity p plus 7 is equal to 3 times the quantity p plus minus 4. That's, what did I say equal to? I meant plus. -7 times quantity p plus 7 plus 3 times quantity p minus 4 is equal to -17. So 2 sets of distribution here. This -7 is being distributed to that set of parentheses, and the +3 is being distributed to that set of parentheses. So I need to take care of both of those. Now you can do them in the same step, which is what I'm going to do. So -7 times p is -7p. -7 times 7 is -49. Then plus 3 times p, which is 3p. And then 3 times -4 is -12, so that's a -12 there, which is equal to -17. So I took care of both of those distributions. Now I got to put my like terms together. So I have 2 terms that have the variable with them. -7 plus 3 gives me -4, so -4 times p. And then -49 and -12 gives me -61. They're both negative terms, so I need to add them together. So -49, -12, -61 is equal to -17. I usually try to line up my equal signs there. I didn't do a very good job of that. So I can slide that over, but I think it's kind of helpful if you try to keep your equal signs all together. Then the next thing I would do is cancel this -61 here. So I'm going to add 61 to both sides. And when I do that, I have -4p, which is equal to -17 plus 61. -17 plus 61 is 44. And the last thing, divide by that coefficient. Divided by -4, I get p is equal to -11. Let's try number 3. In number 3, I have 8 minus 4 times the quantity, -5a minus 2 is equal to 12a. So distribution of this -4 here. -4 needs to get distributed to both parts inside that parentheses. So the a and a doesn't get touched right away. Then I have -4 times -5, which is positive 20a. Then negative 4 times negative 2, which is positive 8, is equal to 12a. I have a couple like terms here, 8 and 20. So 8a plus 20a gives me 28a plus 8, still equal to 12a. Now I have a's on both sides, so you have a couple of choices. I usually like to move the smaller one. If I move the smaller one, the 12, that leaves me with nothing over here, so I would need to represent that with a 0. So if I move that, negative 12a, my negative 12a, or subtracting 12a, so 28 minus 12, that leaves me with 16a plus 8. And then over here, I've gotten rid of those, which means I'm left with 0, or in other words, nothing. And the way we represent nothing in math is with a 0. So then I need to subtract the 8. So I have 16a equals 0 minus 8. Now if I start at 0 and subtract 8, I'm at negative 8. Last step, divide by the 16. And that's going to leave me with a fraction there, but I can reduce it. 8 out of 16 is 1/2, but the whole thing is negative. So negative 1/2 is my answer there. Last practice question from yesterday. So we have 9 times the quantity b minus 4 minus 7b is equal to 5 times the quantity 3b minus 2. Okay, so first thing, distribute the 9 to both parts. And also distributing the 5 to both parts on that side. So over here, 9 times b gives me 9b. 9 times negative 4 gives me negative 36. I still have that minus 7b, which was already there. On the other side, 5 times 3b is 15b. 5 times negative 2 is negative 10. All right, so now check for any other like terms. I have a 9b minus a 7b, so I can put those together. 9 minus 7 is 2, so I have 2b minus 36 is equal to 15b minus 10. I also have variables on both sides, so I'm going to subtract the 2b, move it over so that it's gone from the left and it's together with the other b term on the right. So I have negative 36 is equal to 15 minus 2, which is 13b minus 10. I'm getting down to the wire here. Add 10 to both sides. That's negative 26 is equal to 13b. And don't forget that you can use your calculator to help you out, or at least to check if you think you're on the right track or if you want to make sure. So now I have division of 13. Negative 26 divided by 13 is negative 2. So b is equal to negative 2. All right, so now those were all our steps for solving equations yesterday and some more practice with solving equations. We're going to use a lot of these steps today when we solve inequalities, but before we do that, we just want to refresh, what do the inequality symbols say or mean? In other words, so the very first one up at the top says less than, or in other words, not as much as, or fewer than. Okay, the next one is greater than. Greater than is also known as more than. Once I put that line underneath there, now I'm looking at less than or equal to. That's also known as at most or no more than. So you can start at that number and go down. That's kind of what that's saying there. And the last one is greater than or equal to, which is no less than or at least. So I want to be at least something, which means I can start at that number or get bigger. And then the one last thing that we need to think about when we're solving inequalities that's different than equations is that we need to reverse the inequality symbol when multiplying or dividing by a negative number. We do the division of a negative number a lot. It's the multiplying by a negative number that throws us. So it's both of these things. When we multiply or divide by a negative number, we reverse the inequality symbol. All right, so let's flip over to the back of your notes and let's try some more examples. In number 5, I have negative 4 times the quantity 5w minus 8 is greater than 52. So the first thing I notice that I need to do is I need to take care of that distribution. Negative 4 times 5w is negative 20w. Negative 4 times negative 8 is positive 32. Greater than 52. No other combining that I need to do. Variable is only there once, so the next thing is to get rid of that constant. Subtract 32 from both sides. That goes away. Negative 20w is greater than now 20. 52 minus 32 is 20. And then the last thing is to divide by negative 20. Okay, now I'm dividing. The very fact that I said the word divide means that I need to take a look at what I'm dividing by, and I need to check if I need to flip my symbol. In this case, I do. I'm dividing by a negative, so that means this greater than symbol is now going to turn into a less than symbol. So I'm looking at W is less than negative 1. So there's my inequality, but now we need to talk about how we graph this. So on your graph, it's always a good idea to have 0 somewhere. That doesn't mean 0 needs to be in the middle, but it just needs to be somewhere on your graph because that'll be on your number line. That'll be a good reference point, and then you can count from there. And we don't always count by ones. In this case, we will because we're only going down to negative 1, but sometimes we count by other things too. So let's say I put my 0 up here. Here's a 1, here's a 2, here's a negative 1, here's a negative 2. You just want to put a few points on there, enough to give us the scale of how it would look if we kept going down the number line, and then graph it. So I need to talk about the circles when I'm looking at less than or greater than, which in this case I'm looking at less than. So if I have less than or greater than, that means I want to use an open circle. If I have less than or equal to or greater than or equal to, that means I want my circle to be filled in. Okay, this might be an important note for you to write down on your page. I know there's not a clear specific spot for you to write it, but maybe up in the corner somewhere or down at the bottom, somewhere you have some open space. That just tells you what type of circle to use. So in this case, I have, I'm using less than. That means I want an open circle. So at negative 1, I have an open circle, and my numbers are literally less than negative 1. So where do the numbers go if they're less than negative 1? They go down to the left. So that's where I'm going to shade. And I just put a nice arrow at the end so I know that it's going to keep going. All right, let's try number 6. I have a 13 minus 4k is less than or equal to 27. No variables to worry about on both sides, no distribution to take care of. I just need to solve this. So I'm going to start by subtracting the constant. My constant is a positive 13, so I need to subtract it to make it go away. I'll use a different color so that's not so blinding. So I'm going to subtract the 13. That goes away. Don't forget that that negative's there. So negative 4k is less than or equal to 27 minus 13, which is 14. Then I have negative 4 times k, so I divide by negative 4. And I'm left with k is now, haha, divided by a negative greater than or equal to negative 3.5. Okay, so I flipped my inequality symbol because I divided by a negative number. All right, so now let's go down and graph it. So I need to go down to negative 3.5. Since I'm going down, I'm going to put my 0 up a little bit higher this time, and that's fine. Again, 0 doesn't have to be in the middle. It just needs to be on there somewhere. So 0, negative 1, negative 2, negative 3, negative 4, negative 5, and you could keep going if you want to, but we know we're going to negative 3.5. Negative 3.5 is going to be halfway between the negative 3 and the negative 4, so right about there. My sign is included, which means I fill in my circle. So I have a filled in circle, or in other words, what we call a closed circle at negative 3.5. I want my values to be greater than negative 3.5, and numbers that are greater than that go to the right. So I'm going to shade up to the right here. All right, next one. 9x plus 5 is greater than 4x plus 15. No distribution, but variables on both sides, so I'm going to fix that. Subtract the 4x to move it over. 9x minus 4x is 5x. Subtract the constant. 5x is greater than 10. And divide by the coefficient. X is, now in this case, I divided by positive 5. I still did division, but I divided by a positive 5, so I do not need to flip my sign. So I have x is greater than or equal to 2. And throw some numbers up on my number line. 0, 1, 2, I know that I want my closed circle at 2, I'm sorry, hello, open circle, not included, just strictly greater than, so open circle at 2, and numbers that are greater than 2 go to the right, 3 is bigger than 2, it's to the right, so I shade up. Now, a lot of you may remember shading or drawing the arrow in the direction that the symbol points. You can think of it that way as long as your variable is on the left. So your variable has to be on the left-hand side if you're going to think about the arrow matching the symbol. So see how my arrow is pointing this way? My symbol is pointing this way. That is true as long as your variable is on the left. Your variable has to be on the left-hand side for that to be true. So now for number 8, I have b divided by -3 plus 5 is less than 10. So I don't have any distribution, I don't have any like terms to combine, but I do have a constant to get rid of. So I'm going to get rid of that constant here by subtracting 5. When I subtract 5, that goes away. I'm left with b divided by -3 is less than 10 minus 5, which is 5. Then the next thing that I do is I need to multiply to cancel this division. b divided by -3, I need multiplication to get rid of that. So multiply by the -3. That cancels the division of that. And then I'm left with b, which is what I want. But now check what you multiplied by. I multiplied by -3, which means my symbol goes to greater than. So I have b is greater than -15. So there's my inequality. Now I need to go all the way down to -15. So I'm going to put 0 up here. Now we don't always have to count by ones. Maybe this time I count by fives. So I could go down to -5, -10, -15, -20. Up here would be +5. And then I can draw in my circle and my arrow. So in this case, I want an open circle at -15. I want my values to be greater than, which is to the right. So I shade them up. All right, 3 questions left. We can do it. So in number 9, now we're looking at a situation that we have to write and solve. It says an amusement park charges $15 for admission and $2.50 for each ride. You go to the park with 60 bucks. Write and solve an inequality that represents the possible number of rides you can go on. So you're trying to figure out how many rides can you ride? Number of rides you can go on. So I'm going to say X is the number of rides. So I need to think about what am I spending? When I walk in the door, I'm automatically spending a $15 flat rate. So I have $15, but then in addition to that, I need to spend $2.50 for each ride. Okay, those are the things that I'm spending at the park. I know that I walk in there with $60. Okay, so that's going to be on the other side. But then the question is what goes in the middle? This is like what you spent. This is what you have. We always want to spend less than what we have. Now we could spend all 60 bucks, but we still want it to be 60 bucks or less. So less than or equal to is going to be my inequality symbol. And then I need to go ahead and solve it. So I have a constant to get rid of. Get rid of that 15. That goes away. 2.5x is less than or equal to 45. And then a coefficient of 2.5, divide by 2.5. I'm dividing by a positive, so I do not need to flip my sign. So I have x is less than or equal to 45 divided by 2.5 is 18. So I can ride at most 18 rides. All right, let's take a look at number 10. In number 10, it says you have $18.50 to spend on pizza. It costs $14 plus 75 cents for each topping, tax included. Write and solve an inequality to find the maximum number of toppings the pizza can have. So, again, I want to look at what am I trying to find? I'm trying to find the number of toppings. So that's going to be my variable. X is the number of toppings. So then let's take a look at what we're going to spend versus what we have. And you can probably already guess this. We always want to spend less than what we have. We could spend equal to what we have, but that's the inequality symbol we are going to use here, regardless of what the numbers are. All right, so you have $18 to spend on a $18.50 to spend on a pizza. So I know I can put that over here. Hello, not 20, $18.50. So 18.50 is what I have. On the other side, the side that I'm spending, it says it costs $14 plus 75 cents for each topping. So $14 plus 75 cents for each topping. So 75 cents times X. Now I need to solve it. So there's my inequality. Now I'm going to solve it. Subtract the 14. This goes away. You have 75 cents times the toppings is equal to $4.50, and then divide by the 75 cents. So I end up with x being less than or equal to, my sign stayed the same because I divided by a positive, and 450 divided by 75 cents is 6. So I can have at most 6 toppings. Or in other words, less than or equal to 6 toppings. Notice that, by the way, I have words with my answer, words in the question, words in the answer. Make sure you put a label with it. Okay, last question. For Park College's basketball games, it costs $15 to attend. A season pass costs $170. At most, how many games would you attend at the $15 price before spending more than the cost of a season pass? Okay, so you're trying to figure out the number of games. So that's what I'm going to call my variable. Okay, so now I need to think about the two sides. Each side of the inequality symbol, one is going to be just the cost per game, and the other side is going to be the season pass. That's the other version or other variety that I could have for the game. So we want to know how many games can you attend at the $15 price before spending more than the cost of the season pass. So we want this cost to be less than the cost of a season pass. So that's going to be our inequality symbol. All right, so now let's fill in the values. The straight up cost per game is $15 to attend. So it's just $15 times the number of games. I guess I used X there so I could fill that in with the right variable that I picked. $15 times X. And I want that to be less than the cost of the season pass, so I'm going to set that less than 170. And then only one step to divide this here. This is just a one basic, simple one-step equation. I end up with x is less than 11.3, and I think it was 11.3 repeating there. Okay, so now let's talk about what that means for a second. So that means x has to be less than 11.3 repeating games. Now, I'm willing to bet if you went into a game, paid 15 bucks, left after a third of it, you're not getting some money back. There's no way that you can pay for a third of a game. So we have to round this to the game below it, okay? Because we can't spend more than 11.3 repeating. I can't pay for a portion of a game, so it's kind of like I'm just taking off the fractional part. So really I'm looking at most 11 games. Is what I can go to. All right, so that concludes our video for today. Thanks for listening, and don't forget to check off your notes with Ms. Johnson, and then you can have your practice sheet. See you tomorrow.